Our planet is a symphony of interconnected systems. The oceans and the atmosphere are locked in a constant dance, their intricate movements shaping the patterns of our climate. El Niño and La Niña, these seemingly innocuous names, represent powerful shifts in this delicate balance. They are not storms, nor are they hurricanes. Instead, they are large-scale climate patterns arising from variations in sea surface temperatures in the equatorial Pacific Ocean. El Niño, Spanish for the little boy, typically emerges around Christmas time, hence its name. It is characterized by unusually warm waters in the central and eastern tropical Pacific. La Niña, the little girl, is its cooler counterpart. These phenomena are opposite phases of the El Niño Southern Oscillation, ENSO cycle, a natural climate pattern that swings back and forth every few years. Imagine a vast seesaw, its two ends representing the eastern and western tropical Pacific. During El Niño, the warm waters pile up in the east, tilting the seesaw. La Niña, on the other hand, brings cool waters to the surface in the east, tilting the seesaw in the opposite direction. These seemingly simple shifts have profound implications for weather patterns across the globe. The Pacific Ocean, the largest and deepest of Earth's oceans, plays a pivotal role in our planet's climate system. It acts as a massive heat reservoir, absorbing and releasing vast amounts of solar energy. Changes in sea surface temperatures in the Pacific, such as those associated with El Niño and La Niña, can disrupt atmospheric circulation patterns, triggering a cascade of effects that ripple across the globe. During El Niño, the warmer-than-average waters in the central and eastern Pacific heat the air above, creating an area of low atmospheric pressure. This disrupts the normal trade winds, which typically blow from east to west across the Pacific. As a result, the Pacific jet stream, a fast-flowing air current high in the atmosphere, shifts southward. These shifts in atmospheric circulation patterns can have far-reaching consequences. El Niño is often associated with increased rainfall along the western coast of South America, leading to flooding and landslides. Conversely, it can bring drier conditions to Indonesia, Australia, and parts of Southeast Asia, increasing the risk of drought and wildfires. The effects of La Niña are generally opposite to those of El Niño, with cooler-than-average waters in the central and eastern Pacific influencing weather patterns in a different way. For millennia, the people of India have lived in sync with the rhythm of the monsoon. This annual wind reversal, driven by the temperature difference between the land and the sea, brings life-giving rains to the Indian subcontinent from June to September. The monsoon is not merely a weather phenomenon. It is the lifeblood of India's agrarian economy, upon which millions depend for their livelihoods. The Indian monsoon is intricately linked to the complex interplay of atmospheric and oceanic processes, including the El Niño Southern Oscillation. During a normal monsoon season, moist air from the southwest Indian Ocean is drawn towards the Indian subcontinent, where it rises and condenses, forming clouds and bringing rainfall. The strength and distribution of these monsoon winds, however, can be significantly influenced by the presence of El Niño or La Niña. El Niño, with its warm waters in the central and eastern Pacific, tends to weaken the monsoon winds. This is because the warmer waters in the Pacific create an area of low pressure, which disrupts the pressure gradient that drives the monsoon circulation. As a result, El Niño years are often associated with reduced rainfall over India, leading to drought conditions. Section 4. El Niño's grip droughts and their echoes. The spectre of drought looms large in India's history. El Niño events have been implicated in many of India's most severe droughts. These droughts have profound implications for agriculture, water resources, and the economy. During El Niño years, weakened monsoon winds result in delayed rains and prolonged dry spells. Crops wither, leading to reduced yields and food shortages. Farmers bear the brunt, plunging them further into debt and poverty. Water scarcity affects every aspect of life, from drinking water to industrial production. Hydroelectric power generation also takes a hit as reservoir levels plummet. The ripple effects impact livelihoods and exacerbate existing inequalities. Section 5. La Niña's embrace floods and cascading consequences. If El Niño brings the threat of drought, La Niña often heralds the opposite: excessive rainfall and the risk of floods. While abundant rainfall is generally considered beneficial for agriculture, excessive rain can be just as detrimental as too little. La Niña, with its cooler-than-average waters in the central and eastern Pacific, tends to strengthen the monsoon winds, leading to above-average rainfall over India. During a La Niña year, the intensified monsoon winds can bring torrential downpours, overwhelming rivers and causing widespread flooding. Floodwaters inundate homes, businesses and agricultural lands, causing extensive damage to property and infrastructure. The human toll of these disasters can be devastating, with loss of life, displacement and the spread of waterborne diseases. The impacts of La Niña-induced floods, however, go beyond immediate destruction. Floodwaters can contaminate water sources, leading to outbreaks of diseases like cholera and typhoid. Agricultural lands remain waterlogged for weeks, damaging crops and disrupting planting cycles. The economic consequences of these disasters can be crippling, particularly for vulnerable communities that lack the resources to cope with such shocks. Section 6. Predicting the unpredictable, the quest for accuracy. Predicting El Niño and La Niña events can be invaluable for mitigating their impacts. Forecasts help farmers make informed decisions about planting and harvesting, water managers optimize reservoir operations, and disaster relief agencies prepare for potential floods or droughts. However, predicting these complex climate patterns is no easy feat. Scientists rely on observations, statistical models, and computer simulations. They monitor sea surface temperatures, atmospheric pressure, and wind speeds. The accuracy of these forecasts is limited by the climate system's complexity. Despite challenges, progress has been made in improving forecasts. International collaborations have enhanced our ability to monitor the Pacific. Advances in computing power have led to better simulations. The quest for more accurate forecasts continues, crucial for building resilience. Section 7. Navigating the future resilience in a changing climate. As our planet warms due to human-induced climate change, the delicate balance of Earth's climate system is being disrupted in unprecedented ways. The frequency, intensity and duration of extreme weather events, including those associated with El Niño and La Niña, are projected to increase in the coming decades. This poses significant challenges for India, a country already vulnerable to the impacts of climate variability and change. Building resilience to these challenges requires a multi-pronged approach. Strengthening early warning systems, improving water management practices, promoting climate-resilient agriculture, and investing in disaster preparedness are all crucial steps. Equally important is the need to address the underlying drivers of climate change by transitioning to a low-carbon economy and reducing greenhouse gas emissions. The future is uncertain, but one thing is clear. Our planet's climate is changing, and the impacts of these changes are already being felt around the globe. By understanding the complex interplay of climate phenomena like El Niño and La Niña, investing in science and technology, and embracing a spirit of collaboration and innovation, we can navigate the challenges ahead and build a more sustainable and resilient future for all.